Gold. And all the music is stolen, so I'm not gonna play it. It's just playing Space Jam, so that works. And then we stole all the screams from Super Nintendo games from the 80s. Anyway. Making you feel old? What? Space Jam. Space Jam 2 is supposed to come out, right? But yeah, we just used we used a C++, like we used Qt for running it in. Yeah, this is like the baby's first simple as Windows application. But yeah, we just like slotted Fmod in there, used a custom renderer in on Fire TV with just a Java renderer for sprites, and then Qt for Windows, and just proxied in the X input states and everything. And then on the web, and they all use the same JavaScript and HTML files, and they all just run WebKit. So that was pretty cool because a lot of game jams and other stuff like that. It's nice to make a game, but it's also nice to be able to send it to people and just be like, yeah, this thing works on like literally any Android device. If you've got a Bluetooth controller, it works on your PC. It works in your web browser. It just doesn't have controller support on the browser. All right, so I think that fixes stuff for everything. So those bugs were the today is, well, I started working on, I don't know. Let's count this as Friday. So the only bugs that we got left is we've got errors with the ball pointer in math with the aspect ratio, and we also have an error with disconnect where I want to add a bit more information to it. Yeah, like the game that we have right now only runs on Windows, and that's kind of unfortunate, but it's just what we got. Well, it runs on Windows, but the server can run on Linux. So there's at least that. So we can compile it for Linux. The UI doesn't work for Linux. So, And the game, the amount of people who actually are Linux or Mac gamers is so small that it's really, and especially with me and Adam both not having any Macintosh computers, we wouldn't even be able to make our money back just of like buying a damn test machine. It's not necessarily Windows specific libraries for Chromium, that it's more of the I think there's some stuff in there for the Chromium stuff that's screwed up and has to be customized because there's always some bullshit compile error with OpenSSL or something like that. So it's not that we couldn't get it working on that. It's just that we won't. Yeah, exactly. I think the only people that really support Mac gaming or whatever are probably Blizzard. ID as well. Yeah. I mean, it makes more sense if the margins are there. Like, if you need another 5% of the user market, another 5% sales is a lot of money when you're selling a lot of copies of your game. But when you're not selling a lot of copies of your game, 5% is not a huge deal. Especially if you're a larger company where 5% is literally your entire profit margin. Sometimes. Okay, so ball pointer stuff, that's in the player proxy actor. I don't know if it's really the shaders and the graphics that make cross-platform development difficult. It's a lot of the other crap like input and your third-party libraries that everybody depends on. That's what holds people back, I think. That and testing, because like supporting different types of renderers and all that sort of stuff is really common for a lot of games. And compiling your game logic and making it in such a way that it works on, every platform is also pretty damned easy. It's more the rest, just like file access and getting your inputs on your controller and whatever the hell UI solution you have not being supported. It's that sort of shit where you're like, crap, I've got to figure out which monitor is the main monitor and then put the window in the middle of it. You're like, well, how do you figure that out on every platform? It's like, shit. Even networking in sockets is pretty simple and pretty much solved. There's a lot of good wrappers for all that, but all right, so getting the indicator position. So the ball pointer math is messed up right now. So if we've got a window here and we've got a ball over here, the math that we need to do is we have our inner box. And we need to take the center of our screen and we need to basically get this line here and then get this point. So how do we do that? Well, we need so basically if we've got these, if we take this guy and we move him over here, we can get a line segment and we can do our intersects. So we're basically intersecting this line here with all four of these, and we do all four and it should clamp it. Hello, Furry McGee. What GPUs are good for cross-platform? I have absolutely no idea. So sorry, I can't really help you out too much there. Alright, so we need to figure out the actual position of the camera. Not the position of the camera, but the position of the middle of what the camera's looking at. Which is going to be, we've got our camera, and it's looking out across here, and it's looking at a downward angle. So what is that position? Our height here is going to be what? The sine of our angle. And then we just add that to our clamp to this location and do that. Yeah, I pretty much have just been running with NVIDIA cards forever, and but there's no real reason why. So what is this? So if camera data, yeah, I didn't write this code. This is actually some of the only code in the entire game that was written by somebody else. So I'm having to kind of redo it from scratch to figure out what the hell was going on here. So he's taking the tangent degrees to radians of our downward angle times game space pause x. So alt pause y minus equal camera offset. Alright, so it's going to be the camera data, downward angle. And that's going to go 0 to 1. But we multiplied by the distance we are from the game space pause. Yeah, so it's going to be our x because we're looking at 0. So that might have just fixed it. I think that's how everything else works here. Can you take the viewport size and just divide width and height by 2? That's pretty much what's going on. And let's look up our F-math just to make sure we've got these. All right, so it takes segment start, segment end, segment start, segment end, and then the intersection point. So since I didn't write this code, I'm just going through it slowly. Because I wrote the original thing, but it didn't take into account the offset for stuff. So let's see what this guy is saying here. Come on, Visual Studio, let me do this. So our target is 0, blah, blah. So what is our screen percent? I need to just print this. I need to just add some prints here. Alright, so we're going to get target dot y, target dot z, screen percent, and half width. Offset the y-axis according to the player position. Not really sure what you're going for there. The player position is not what the camera's looking at. So So player position doesn't really matter for this stuff. It's where the camera's looking when we're looking through space, and kind of part of the indicator stuff actually has to put an actor into the world in that spot, because it's a piece of UI that's actually not in WebKit because it needs to be perfectly updated in line with the game. So it's an actual actor that ignores like the depth buffer and stuff like that to draw the indicator. So I just need to convert that properly into like screen space stuff, and since I don't have any like libraries that I've written for that sort of thing to help out, because it's the only thing that does it, so whatever. And a lot of this stuff is also like when you're working in a new project, you never know if their math libraries are doing what you think they should be. Okay, so the target is at that location. Our screen percent is 0.8, our bounding box is 1800 inside of... Why aren't we getting... Yeah, that'll screw it up. Yeah, the player follows an act. I mean, the camera follows an actor around, but there's a whole bunch of stuff to figure out, like easing and which way the player's looking, and if you're holding up and down, and all this other stuff. So basically, the camera's looking in a place. So it knows where it's looking. I just need to get the math in here, and I just want to verify that all the math is proper, because when you're working with different math functions, you're never really sure if you're speaking the same language. Like, okay, this downward angle is in degrees, but this thing expect radians, and you never know if the math library actually is consistent with degrees and radians across itself. You never know. They got be like, well, the tan function takes radians, but the sine function takes degrees. You're just like, what the hell? Why? It's like, well, because we do. Truncating flows. Yeah, this one snaps. This thing does a seal for no damned reason. Okay, so the target is... we are at... Our screen percent is 80%, our bounding box is 1800 by 900 inside of 3000 by 1500. So 3000 by 1500. So what would we expect for the inner size to be? Our bounding box should be it should be 2400. Like so our inside here is just wrong. So okay, so what? So this is just trash. So it's screen percent half width, half height. What we want to do is take our original, like get camera width, get camera height. Yeah, this is dumb. Let's grab the camera width and, you know, just do these calculations better, because this isn't correct at all. It's a bunch of trash. All right, so our actual width is going to be equals width times screen percent. And our half width and half height is just going to be actual width times 0.5 and this times 0.5. And then we're going to subtract and do some other crap. No, we're not going to do any of that. It's there. We have our width. Alternative position is game space position Y, game space position Z, 0. Alt target is okay. Screen percentage is F, half width, half height, and then is it taking the 80% into account? Yeah, it looked like it was taking the 80% into account kind of wrong. As in, when the guy implemented this feature, I think he mistook what screen percent was supposed to be. And it looked like it was kind of squashing this thing in, because it's like a window within a window for us. So I mean, this might just fix it, so that would be nice. If it's not, then I'll have to look through the intersect functions and make sure there's not like some copy paste error or passing in the wrong corner or something like that, you know. Well, that's looking like it's correct. So I think we got that solved. Let's add a couple bots, and the team indicators are all sorts of fucked up. Our screen percentage is 0.05. Yeah. So let's go to our team indicators and see what they do. Because they're looking like they're squished way in there, and I think I got the wrong percentage. Screen percentage clamp is 0.05. Yeah, okay. So it needs to be, you know, something like 0.9. Let's try that. Yeah, it's squished all the way into, you know, the very, very center. Yeah, so I think what probably happened here is that the person that implemented the feature did not understand the actual idea behind what those numbers should be, and these look correct now. Like that person's right down there. Yeah, because it's a pretty simple math operation. Like just intersect a few fucking lines. So I think what happened was just a simple did not understand what screen percentage was supposed to change with a couple of bad multiplications. Because the only original bug that the guy was fixing was that it wasn't taking into account the height of the camera, the downward angle with the camera, because of some naive math. And also, I think the tangent was wrong. I don't think that was the correct thing. I think he meant sine when he was actually doing the tangent. Degrees to radians. Well, is it? I mean, that's going to give us something from. It's going to be a downward angle of like 2. So 0.2 times that. Well, let's just. I think this might be wrong. I think the y offset might be wrong. Because I didn't put sine in there. Let's just play and make sure I didn't screw anything up when I just refactored that crap to take out all the proposed script. But this is going to go from 0 to 1.4, whatever, multiplied by the camera distance. So it's, I mean, is that the sine? Is the sine just the value of the degrees and radians? Because if that's true, then like we're already done, because radians are mathematically defined that way, right? So did we just skip a step and be smart people by complete fucking accident? I'd say I'm okay with that, if that's the case. Yeah, that's looking correct. Not bad. Try different aspect ratios. Yeah, the team indicators are supposed to be pretty unobtrusive. So I'm not really too worried about tuning the sizes too much with that. But yeah, I can see where you're coming from. So I think the other thing is probably the scale. Yeah, it's probably this like get distance from screen thing. What is this clever bullshit? Alright, so I think that'll fix our off-screen, on-screen stuff. The other thing is that the scale of the object is not changing with the size of the screen. So that would be the other reason why we'd have differing views. I think this thing was at 80% or something. We might want to move it a little out. Alright, so it looks like there's some other functions too that may have had some odd math in them. Did I use blackboards for the AI? Nah, the AI is real stupid. I can crack it open here. The bots basically, they use a virtual controller, so they literally are using an Xbox controller. Well, they're literally using a virtual Xbox controller. So basically, they do things like if their target is to the left, they hold the left stick, and if their target's above them, they hit the A button and shit like that. Like they're they don't actually do anything special. It's pretty funny. Like, they don't even have a concept of what the hell jumping is. They just like, well, if someone's above me, just keep slamming on that A button and hold it down, and try to double jump if our velocity goes negative. So I find that writing simple AI that way works a lot better than anything else, because then you get like the completely emergent behavior out of them. Yeah, and it's got a state machine, and the state machine only changes like what the target is. So that's pretty much all it is. Let me just double check this real quick. So how come this is saying that it's is target off screen? Should be. If target off screen, this should be returning false. So off screen should be false. So which one of these checks is target Z? So half Z is the height. That's true. So what do we got? So we've got that, and our half width is 1954, and our half height is 1500. So if our half width is 1500, like, I mean, this, I mean, how big is this box? This is a 600 by 600 box for this guy. So half width and half height should be, you know, I'm going to just do this again here. $1,500 and $1,500. All right, so they're the same. Good. That's what I was wanting. The target location is and our player proxy actor is here. All right. So we're looking at what's the downward angle? 2.5. And our X is 7,000, so it's basically... Why are things freezing? Alright, there we go. So that's going to be 0.0436. So the reason why this is wrong is because it's going to be the wrong value. Alright, so what's the... It's that our downward angle isn't working properly. Still, that's what's going on. It's it has to do with us not taking the distance properly into account here. So the distance is going to be we need to multiply this. So it's going to be the downward angle so what we need to do then is do what? 7242 times 7242. And then we need to do the square root of that. I mean, that's really the difference of 1, so it's not going to be what we're dealing with. Alright, so if our z is greater than our position, z plus our half height, that's why I hate when you have this clever shit here. I should probably just get rid of this cleverness. Yeah, z is up. Alright, so we're saying that it is always on screen unless it's off screen. So if our target is too high in the y, so we do position y plus half height, that'll say we're on screen. If we're below, so it's position minus half height. If it's to the right, if we're greater than plus. You know, this is just the sort of shit that I hate. Like, it doesn't fucking matter. You're trying to do like some or equal crap, so you know you feel better about yourself. That's just stupid. Just do your ifs and you return truths and code like you're an idiot because you just should. And that way you can put